Now let us return to the proof that psi of x is bounded below by a times x. And recall when we did the upper bound for theta of x, we first prove a discrete version. Namely, we prove that theta of n is bounded by some constant times n for all positive integers n. And now for psi of x, we're going to do the same thing. We'll first discretize it. We let n equal to the floor of half of x. Then, by monotonicity of psi of x is bigger or equal to psi of 2n. And now let's prove the psi of 2n is bigger or equal to logarithm of 2n choose n. And we will use this claim to finish our proof. To prove this claim, we're going to use Legendre's formula. And now let's look at the binomial coefficient 2n choose n. By the Legendre's formula from the previous section, this is equal to and observe that both numerator and denominator are finite products, and the exponents will become 0 for large p's. For how large? We can choose the upper bound for p that serves the upper limit for these products. And one choice of such is 2n. But as you can see, when I choose p less than or equal to 2n, it is too generous for the denominator. Maybe you want to say, okay, we should choose p less than or equal to n. But it doesn't matter, because for those p bigger than n, these exponents will always become 0. So if you like, you can rewrite this as p less than or equal to n. But I want to say that this is just equal to the product for all p less than or equal to 2n, because those actual terms will be p to the 0, which are 1s. And now you further simplify this as a product for p less than or equal to 2n of p to the exponents, the summation of the floor of 2n divided by p to the m minus twice of the floor of n divided by p to the m for all positive integer m. And of course, this is a finite sum, because both terms will vanish for large m. And now we take the log of both sides. What do we get? So log of 2n choose n will be the summation for p less than or equal to n of. And now let's look at this part. Let's analyze this sum. As I commented above, the sum is a finite sum, and it will terminate before p to the m reaches 2n. So whenever p to the m is bigger than 2n, both terms will vanish. So we'll do a truncation here. And now we make a very important observation. We observe that the individual summands is either equal to 1 or 0, depending on whether the floor of 2n divided by pm is odd or even. So how do we verify this? To verify, we let 2n divided by p to the m be equal to 2l plus 1 plus x, or 2l plus x, depending on whether the floor of this guy is even or odd. Then it follows that n divided by p to the m is equal to l plus 1/2 plus x over 2, or l plus half of x. Here, x is bigger or equal to 0 and less than 1. And therefore, if you take the difference of 2n divided by pm floor and twice of n divided by pm floor, it is equal to 2l plus 1 minus 2l equal to 1 in the first case. Remember, this is the case when 2n divided by pm's floor is odd. And for the other case, this is equal to 2l divided by 2l, which is 0. And this case happens when the floor of 2n divided by pm is even. And this verifies this equation. But what we actually need is just that each individual segment is bounded above by 1. So now let's go back to this sum. The sum is bounded above just by the summation of ones. And this can be rewritten as m from 1 to, so the upper limit will be log of 2n divided by log of p. If you just take the log of the both sides of inequality, you will see this immediately. And this is simply just the floor of log of 2n divided by log of p. And therefore, log of 2n divided by n is less than or equal to the summation for p less than or equal to 2n of the sum over m times log of p. So now let's move this to here and observe that this sum, we just show that this guy is bounded by the floor of log 2n divided by log of p. So this is an upper bound we got for log of 2n choose n. But the right hand side is precisely equal to psi of 2n. Do you know why? This is because a remark we made much earlier, right after the definition for psi. But the remark over here, the second remark after the definition of psi, we have this identity. The psi of x, the summation for all primes less than or equal to x of the floor of log of x divided by log of p times log of p. And this proves the claim, which says log of 2n choose n is less than or equal to psi of 2n. And now let's finish the proof for the lower bound for psi of x. Psi of x by our choice of n. Remember, n was chosen as the floor of x divided by 2. And by the claim, this is bigger or equal to log of 2n divided by n. And now let's plug in the definition for 2n choose n. This is equal to 2n factorial divided by n factorial squared, which is 2n times 2n minus 1 all the way to n plus 1. And denominator, you get the product from n to 1. By comparing each factor in the numerator and denominator, you will see immediately this is bigger or equal to log of 2n. And this is equal to n times log of 2, which by definition of n is the floor of x divided by 2 times log of 2, which is bounded below by x divided by 4 times log of 2, because we want to drop this floor. And this inequality is true for x bigger or equal to 2. So this proves that percent of x is bounded below by some constant multiple of x. And finally, this finishes the proof that theta and psi are of order x.